The internet has become an integral part of our daily lives, revolutionizing the way we communicate, access information, and conduct business. But have you ever wondered how this vast network actually works? The internet, the magical realm where cat videos reign supreme and where you can find answers to almost any question you have. But have you ever wondered how this vast network of information actually works? Well, let's take a trip down memory lane to understand its origins. The internet as we know it today began as a project called ARPANET in the late 1960s, funded by the U.S. Department of Defense. It was initially designed to be a decentralized network that could withstand a nuclear attack. Pretty cool, right? Over time, the internet evolved and expanded beyond its military origins. By the 1990s, it became accessible to the general public, leading to the explosion of the World Wide Web and the birth of websites, email, and online communities. And here we are today, with billions of people connected across the globe. 1. Understanding Internet protocols. Now that we have a grasp on the Internet's infrastructure, let's talk about an essential aspect of its functioning, Internet protocols. These protocols are like the rules and languages that allow devices to communicate with each other over the Internet. Think of it as a universal translator for computers. For example, when you request a web page, your computer uses the HTTP, Hypertext Transfer Protocol, to send the request to a server. The server then uses the same protocol to respond and send the requested information back to your device. Common Internet protocols. There are various protocols that play a crucial role in different aspects of the Internet. Some common ones include TCP/IP, Transmission Control Protocol, Internet Protocol. This is the foundation of Internet communication, ensuring reliable and efficient data transmission. FTP, File Transfer Protocol, used for transferring files between computers on the Internet. SMTP, Simple Mail Transfer Protocol, enables the sending and receiving of email messages. DNS, Domain Name System, converts human-readable domain names, like Google.com, into IP addresses that computers understand. These protocols work together in harmony, allowing us to perform a multitude of tasks, from sending emails to streaming videos. 2. The role of IP addresses. Every device connected to the Internet has a unique identifier called an IP address. It's like the online equivalent of a home address. An IP address allows devices to send and receive data across the Internet. These addresses come in two versions, IPv4 and IPv6. IPv4 consists of 4 sets of numbers separated by periods, such as 192.168.0.1. IPv6, on the other hand, uses a more complex hexadecimal format, like 2001, 0DB8, 85A3, 0000, 0000, 8A2E, 0370, 7334. Don't worry, though. You don't need to memorize them all. Types of IP addresses. There are two main types of IP addresses, public and private. Public IP addresses are assigned to devices directly connected to the Internet, allowing them to be identified on a global scale. Private IP addresses, on the other hand, are used within local networks to identify devices. They aren't accessible from the Internet. So, think of a public IP address like your home address, while a private IP address is more like your room number within your home. IP address allocation and assignment. IP address allocation is the process of assigning IP addresses to different organizations and Internet service providers, ISPs. This ensures that each device has a unique address to avoid conflicts. Organizations and ISPs typically obtain IP addresses from regional Internet registries, which manage and distribute these addresses. These registries work together to ensure fair distribution and efficient use of the available address space. When you connect to the Internet, your ISP assigns you a public IP address, allowing you to communicate with other devices on the Internet. 3. Exploring domain names and DNS. Imagine if we had to remember the IP addresses of every website we wanted to visit. It would be a nightmare. That's where domain names come in. A domain name is a user-friendly address that represents the IP address of a website. It's like the name of a shop instead of remembering the exact GPS coordinates. For example, instead of typing 172.217.168.46 in your browser, you can simply type google.com, Much easier, right? Domain Name System, DNS, explained. Behind the scenes, the Domain Name System, DNS, helps in translating domain names into IP addresses. It's like a phone book for the internet. When you type a domain name into your browser, the DNS steps in and finds the corresponding IP address for that domain. It's a fascinating process that involves multiple servers working together to ensure you reach the right website. So, the next time you type a domain name, remember that a little bit of magic is happening behind the scenes to bring you the desired web page. 4. The basics of Internet routing. Routing is like the GPS of the Internet. It's what guides your data from point A to point B across a vast network of interconnected devices. So, let's get down to the basics. Internet routing is the process of finding the most efficient path for data packets to travel through the network. It's like navigating through a busy city, except instead of streets and highways, we have routers and links. These routers are like traffic cops, directing your data in the right direction. Routing protocols and algorithms. Behind the scenes, there are complex routing protocols and algorithms that determine the best path for your data. These protocols communicate with neighboring routers to exchange information and build a map of the network. Think of it as a team of navigators working together to find the quickest route. BGP and routing between ISPs. When it comes to routing between Internet Service Providers, ISPs, the Border Gateway Protocol, BGP, takes center stage. BGP is like the superhighway connecting different ISPs. It allows them to exchange routing information and ensure that your data can travel seamlessly across different networks. 5. Transferring data with TCP/IP. TCP/IP is the backbone of the Internet. It stands for Transmission Control Protocol, Internet Protocol, and is a set of rules that governs how data is transferred. TCP handles the reliable delivery of data, while IP deals with addressing and routing. TCP and UDP protocols. TCP and UDP are the two main protocols used within TCP/IP. TCP is like the reliable postman who ensures your data arrives intact, while UDP is more like a speedy courier who delivers your data quickly but without the same level of reliability. Different applications use either TCP or UDP based on their needs. TCP/IP handshake process. When you send data using TCP/IP, there's a fancy handshake process that happens between the sending and receiving devices. It's like a secret handshake between friends that establishes a connection and ensures both parties are ready to exchange data. 6. Internet security and encryption. Internet security is like the bodyguard of the digital world. It safeguards your sensitive information and prevents unauthorized access. From malicious hackers to pesky viruses, internet security keeps the bad guys at bay. Encryption and secure internet communication. Encryption is the superhero of internet security. It scrambles your data into an unreadable mess and only allows authorized parties to decipher it. So, whether you're shopping online or sending secret love letters, encryption ensures your information remains private and secure.